Alright, so we went over just our basic exponent rules in class last time. And so what we're going to look at today is how do we solve exponential equations as we progress towards logarithms. So one of the key things when solving exponential equations is we have a goal of getting the same base, because if the base is the same and we have one base on each side, then we can say the exponents are equal. And so our goal for today is going to be getting the bases the same, and we might have to rewrite some numbers so that way we can take our exponents and set them equal. It also works backwards. So if you have two things you know are equal, give them the same base and it maintains equality. Now we don't go backwards all that often, but we do sometimes. Most of the time we're going from left to right. So if we look at number 1, this has a base of 2. This has a base of 32. So the question we ask ourselves, can we rewrite 32 as 2 to a power? So when I think about 32, if we break it down, it's 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So it's 1, 2, 3, 4, 5 2's. So I can rewrite this as 2 to the 5th. So now I can know that my bases are the same, which means my exponents have to be the same. So x is equal to 5. So this again is something you should have done last year, so we should be just refreshing. How this might get a little more complicated than last year is we just might have more complicated expressions, but the basics are the same. So if we look at number 2, we have 8 to a power to x equals 32. So I just did it over here. I know I can rewrite 32 as 2 to the 5th. Can we rewrite 8 as 2 to a power? And so if I look at my tree here, start at 8, I had 1, 2, 3 2's. So 8 I can write as 2 to the 3rd, with that x still out there as well. Using our power rules, 3 times x, we'll get 2 to the 3x equals 2 to the 5th. And then from here is where we can set our exponents equal to one another. So we'll set 3x equal to 5 so that we can solve and get x is equal to 5/3. Something like number 3, we have 5 to the x. That's prime, so I know I can't break it down any further. So 1 over 25. Well, I know that I can make this 25 to the negative 1, so I can get rid of my fraction by bringing the denominator up and making it a negative exponent. And I also know that 25 I can rewrite as 5 squared. So when I multiply my exponents here, I'll get 5 to the negative 2. So again, my bases are the same. That means my exponents are equal. So x is equal to negative 2. Okay, we're going to keep going on. So here we have number 4, similar to number 3, except that our base is in parentheses to the x power. So, but I'm going to go about it the same way. I'm going to bring my denominator to the top and make it a negative exponent, so negative 1. I also need to convert 64 to 2 to a power. So you can break it down to your factor tree again if you would like. Or if you notice, this is just 2 times 32, so it's going to add one more 2 in there. 2 to the 6th. Multiply your exponents here using your exponent rules. So my bases are the same, so my exponents are the same. So x would have to equal -6. Okay, then we get to something like number 5, where we have a little bit more involvement in our problem. So the ones so far have been pretty consistent with change the bases to be the same, use exponent rules, set exponents equal, solve. Number 5 has a little bit more work to it, but we're still doing the same basics. So let's start by trying to get bases all the same. So I know 3 to the x, I can't change that to be anything smaller. 9, I can make 3 squared. And 27, I know is 3 to the third. So I can change all of these to be a base of 3. So I'll have 3 to the third instead of 27. Here I'll have 3 squared instead of 9. And I still have that 4x plus 1 out there. And I still have my 3 to the x on the bottom. So now I'm using my exponent rules. I'm going to move it up here just so I have more space. I'm going to multiply my exponents, so 3 to the 3x. Now here I have to multiply 2 by both of these because that's all in the exponent up there, so I have to distribute the 2. So we'll have 3 to the 8x plus 2 over 3 to the x. So we've got the same base, but we haven't finished simplifying using our exponent rules. Before we can set our exponents equal, I have to get just one base. I still have 2 bases over here. So because of the division, we can subtract the exponents. So when I subtract 8x plus 2 minus x, I'm going to get 3 to the 7x plus 2. Now I have a single base on either side, and that's the same. So I can set my exponents 3x equals 7x plus 2. From there we can combine like terms. So I'm going to minus the 2 over and minus the 3x over, and I will get x is equal to -1/2. So that one was a little more involved. We had just more steps on our exponent rules. We actually had a lot more to use, so we had to expand it out to a few more steps. But again, the basics were the same. Get a common base, use exponent rules to simplify, set exponents equal, solve for x. Okay, so on number 6, same kind of idea. We just have the same basics, just a little more involved. So here, again, I'm going to start by bringing that 2 to the top with a -1 exponent. Over here, I'm going to change 8 to be 2 to the third. And then I'm also going to make this 2, and again, power to a power, we have to multiply that 4 to both of these. So that'll be 4x minus 4. Now over here, now that I have this as a -1, I also have to distribute this -1 to both of those. So we'll get 2 to the x minus 3. Over here we have like bases being multiplied, so I add my exponents. So we'll get 4x minus 1. So again, we started the same way, got things all to be the same base, and then used our exponent rules to simplify so that we can take our exponents and set them equal to one another. So I'm going to minus the x, add the 1, so we'll get -2 equals 3x, so x is -2/3. Okay, and then the last one for tonight, we'll do, I think I have like 4 more to do in class. Last one for tonight. 7 to the 2x minus 3 equals 1. How do we make those the same base? Well, this one involves a little bit of creative thinking, and we didn't really talk about it much yesterday because I don't remember if it showed up at all on the assignment. But how do you get 1 as an answer to an exponent? So you want to remember that anything to the 0 power is 1. So what we can do is rewrite 1 as 7 to the 0. And when this happens, you can pick whatever base you want. As long as it's to the 0, it's going to be 1. So I could call it 3 to the 0 equals 1, 2 to the 0 equals 1. Anything to the 0 will equal 1. So I'm going to choose 7 purely so that I have matching bases. Now that my bases match, I can take my exponents and set them equal to one another. So 2x is equal to 3, so x is equal to 3 halves. Okay, so this was all about just how do we solve when we can get bases the same. So get the base the same, use your exponent rules to simplify, and then set your exponents equal to solve. So in class, we're going to do, like I said, I think it's 4. Yeah. 4 more examples that are similar. One that's a little bit of a throwback to last semester, beginning of the year. So we'll do that one together in class also. But then our worksheet is going to just be problems like this where we're solving by getting the same base, using our exponent rules to simplify, set the exponents equal, and solve.